Good day. I am going to walk through today a speed run of trying to get a Jetan agent up and running with a minimal alpha beta algorithm. I'm going to start by just making sure that I've got everything built correctly as a starting point. Off in my upper right window, I'm in the Jetan program development area. The contents here are the original contents of this folder, and I have already done a build of the entire system. In my lower right hand corner, I'm in the build area for Jetan, and so I'm going to just demonstrate that it's already built. So you can see here I've got the run Jetan script in the programming area. If I run it, I should be able to do the default, which is to run a manual agent against the random agent. And the screen looks kind of small to me. So the first thing I'm going to do, because of the size of my display, I'm going to change the display size as soon as that quits. Over here on the left hand side is my editor, again in the programming area for Jetan. I'm going to go down to the run Jetan script, find where Jetan display is launched, and I'm just going to add display size. And for my particular display, which is rather large, let's see, how big is my screen? So it's pretty big, and I want to use up at least half of that as I run my display. So I'm going to make the display size be height of, say, 1080. Yeah, a height of 1920. How's that? And a width also of 1920. And add that to the Jetan display command line arguments so that when I run that script, it'll give a size that's appropriate for my display. You might do a similar mechanism. Okay, so now if I run, there, that's better. I can see that a little bit better here. And I can see that I am player 2, coming from the downside here. And I'll just do a couple of test moves here. I'm going to move this piece here that's at column 3 and row 8. Column 3, row 8. And I'm going to move him up and to the right, which is column 4, row 7. Make sure that the move actually occurs. Looks like the game's working fine. I don't want to take the time today to play a manual game. I'm trying to get some software working. So I'll go ahead and let that quit. But we can always come back here and look at that at a later time. The next thing I want to do is go and find some inspiration on how to structure alpha beta agent within Jetan. The first thing I'm going to do is realize that I want my own agent. I don't want to be working on manual or random. I want my own agent, and so I'm going to copy the AI sample random.h into AI, let's see, John Carter .h. I'll use, whoa, that was a improper naming. There we go. That's better. I'm going to name my agent John Carter. And then I see that the ifdef here is based off of the old file name, so I'll update the ifdef to match. I want to stay in the AI Jetan namespace, but I no longer want my agent to be called random. This agent is going to be called John Carter. Notice I'm doing this by copying, so I don't eliminate the random agent. I'm making a new additional agent to add to the system. Okay, there is my constructor and destructor declared so far. The next thing necessary would be to copy an implementation file, and I want to call my implementation johncarter.cpp. Alright, John Carter. Make sure I'm including the correct header file, and wherever random exists, let me replace it with John Carter. Okay, so at this point I should have an agent that plays randomly just like my random agent does, but is named John Carter. To finish off the building and using of that agent, I would go into agentprograms.pm right here. Copy the clause for the random agent. Let's use J for John. Update the header file. I've only got one CPP file at this time at least, and then I'm still in the AI Jetan namespace, so that should be good. Okay, so if I didn't make any mistakes in the copying, I should have an agent called John Carter that will compile. I'll come over to the lower right corner and issue a make command and see if it will build correctly. I can see in here that agent program select was first off recreated because of the work in agentprograms.pm, then recompiled. johncarter.cpp was compiled, and that should be good. Now my agent won't play if I come up here and say run Jetan, because that hasn't been configured as my default agent. I'm going to fix that now. I'm going to show you right here that in run Jetan that the last line here is to run your player, the user's player, the human's player, whichever one you're developing. And so currently it's using the contents of Jetan our agents, arguments. Where is this at? The contents of that file are used to select which agent and give it any options that you want to give to it. So I'm going to go off to Jetan agent arguments.txt and switch from agent M, which is the manual agent, into agent J, which, remember from our agent programs PM, was the key that I gave here when I specified it. So now by changing that file, I should be able to say run Jetan and watch John Carter play against a random agent. They are both acting randomly. No intelligence yet. And if you can see up here, it's kind of small font, but it says John Carter here and random there. Okay, I don't actually want to sit and watch this play to the end, so I'm going to do a Control-C, which should kill the John Carter agent. And after the John Carter agent stops running, I get my command prompt back. I can say kill all Jetan server, and that should stop the server from running, which will stop the other agent as well as the display. Okay, so I'm at a good point. I've actually got my own agent. It doesn't do anything new, but it's my agent that I can modify without messing up any other agents. So I'm actually going to go ahead and use Git here to record my progress so far. John Carter is a random agent now. Okay, so with that committed, I am in a good place to start actually making some meaningful changes. If I mess up now, I can still go back to this base point and don't have to recreate that work. Okay, so my inspiration now will come from going over to the Mancala agent and seeing, whoa, there's a whole bunch of different implementations here. Which one do I want? I'm going to go for the straightforward alpha beta, which is already has Minimax implemented with the alpha beta extensions to it, and I want to just copy the structure that exists there into my John Carter agent. So in the bottom screen, I'm going to leave the Mancala alpha beta agent displayed, and in my top portion, I'm going to go into the John Carter header file right here and say, okay, well, the alpha beta has, in addition to its constructor, destructor, and program method, method for pick move, one for max, one for min, and one for evaluate. So I'm going to go ahead and copy all of those methods and say John Carter's going to want one of all of those. Now there's a difference though, because I don't want a Mancala board, I want a Jetan board, and I want to make sure that I'm getting that right. So let me go into aijohncarter.cpp for a second and verify what is the name of the board type. Okay, for Jetan, it's AI Jetan board. That makes sense. That's what I expected, but I better double check to make sure I'm not assuming false things. So I'm going to replace AI Mancala board with AI Jetan board. And then leave the rest of that structure alone for now. I also notice that there's this type fly data that I brought forward. Everything else in here is either in the AI Jetan, which I should pick up from the AI Jetan header file here, or it's a built-in like an int or a double. So it's just the ply data I need to look for. I'm going to come back over here to the AI sample alpha beta header file, and if I look for ply data, it's not declared in here, it's just used. Well, I don't think it's in the Mancala header file, so it's probably in the AI sample minimax, which was included. So let me go to AI sample minimax.h and look for ply data. I type correctly, and there in fact is a declaration of ply data. So I'm going to, realizing that I need that, and I'm not going to go implement a minimax straight up, I'm going to go copy that class here into my John Carter agent files, and instead of Mancala, I want it to be a Jetan move data. Does Jetan actually have a move data? I'm going to go back into the CPP file for John Carter. Jetan does have a move data type, so let's assume that's fine for now. This ply data keeps track of the utility of a particular branch in the tree, the move that we would take to get to that utility, and whether that move is actually configured, if move OK is true, and if it's not configured, if move OK is false. Okay, now bringing ply data forward means that I probably need to go at least bring its constructor forward. That's the only method. So let me go find its constructor. I'm going to assume that's in AI sample minimax.cpp, since it was declared in the .h for that version. There we are, ply data. I'm just going to copy that and go into John Carter's CPP file, and up here at the top, implement that. Okay. So hopefully I've got the ply data picked up correctly now. And I don't see any other new types there, so I just see that I need to implement those 4 new methods. Unfortunately, with something like Minimax or Alpha Beta, it's a all or nothing. It's kind of hard to do a little bit. So we'll probably need to implement all 4 of those methods in order to get something that builds. Okay, I'm going to go back to AI sample alpha beta.h, which is where all these things were declared. Oh, we better copy forward max depth, because that's probably going to be important for us. Okay, for our depth cutoff. Okay, let's go into AI sample alpha beta.cpp, the implementation file, and let's see what kind of things we need to start bringing forward into John Carter.cpp. So first off, I see this my infinity constant, and it looks like pick move uses it, max uses it, and min uses it. So if I'm going to be copying those methods forward, I probably need to copy forward something they depend on. All this infinity is to make sure we have a number that's bigger than any utility we might actually calculate, so that we can say that it's either much, much better or much, much worse than anything else we could find. Okay, next thing that I'm going to do is jump down here to pick move, max, min, and copy all of those forward and work on them for a minute. We'll do evaluate after that. So I'll come down to inside, still inside my nested namespaces, paste those in, and realize that wherever I say alpha beta, I really mean John Carter. Okay. Now let's also look for Mancala. Replace that with Jetan. Those are the brute force things. Let's go walk through the code now. So the pick move is meant to just start the recursion by doing the top level max call in the alpha beta recursion. And it will pass on the current Jetan board, what my player number is, the depth that I'm calling at, so max will be depth 1, and then the alpha value and the beta value to inherit. Remember that negative infinity and positive infinity for alpha and beta mean that we haven't found anything, any ancestors that are better. And then this pick move will return ply data. The intent is then that ply data, in addition to having utility in it, will also have the move to make. And our main program will want to use that move. Okay, let's look at max now. So max receives a board, our player number, the current depth, an alpha and beta value. It initializes its ply data with negative infinity, meaning its current value, the best value it knows about, is negative infinity, which is the worst possible thing for a max node. And then it's going to check to see if the depth is greater than max depth. If it is, then we should do a cutoff. Or it wants to check if the game is over, and in which case we should also stop recursion if the game is over. At which point we want to evaluate the board if the game is over or cutoff is reached, and return the ply data associated with that. Now, at the top level of max, this should not be the case that we either have a winner or that we've exceeded our max depth, and that won't happen. But when we get down in the tree, it's possible for this to happen. And so, let's see here. I'm concerned, is there a board.have winner in the Jetan board? I know there was in Mancala, or the Mancala code wouldn't have compiled. So I'm going to go to the top level of the repository, go down into the environments and into the source for environments. Underneath the agent environments there's Jetan, and inside of there, well, let's see, I see a whole bunch of CPP files. I actually don't want to look at those. I apologize. I want to go into the include so I can just read the method definitions. Alright, and I want to look at the Jetan board. Here we are. The Jetan board then has the following methods. A move method, which takes a move data. That's probably going to be useful for us later. Quit is legal. We'll check to see if a move is legal for a particular user. Winner will return true if this player is currently winning. Have winner will return 0 if there is no winner, 1 or 2 if there is a winner. Okay, so I'm thinking have winner still there, and it still returns 0, which is false if the game is not over. Okay, so I think we're good with that line. Let's continue looking at max. So it looks like here we make a copy of the board that was passed to us. Notice that the board that was passed to us was passed as a const reference, so we're not going to want to go monkeying around with the board. We can make a copy of it then that we can mess around with. From that copy, we get a list of the legal moves that our player can take, and we store them as a const reference to that vector. Now, it's a vector of some number of moves. I'm thinking it's probably around 50 to 100 moves at any point in the game. If instead of making a const reference, we just made that as a vector, we would copy all that data back and do a lot of copy work that isn't necessary if we don't want to modify the vector. And right now, at least, I don't want to modify the vector. Okay, following that, I want to loop over the list of, I want to loop over the list of moves, and for each move, I want to apply them to the board. But I don't want to go changing that board, because that board has a vector of moves in it, and I don't want to change the board and cause that vector of moves to actually change. So instead, again, I make a copy of the board, and then I apply the player move to that player's move to the board. So temp board now is a board that's actually at the next level. Okay, from there, then I'll call min, passing in the temp board, the one where I've made my move. Let min know who I am, and min is the next level down, so depth +1. I'll pass my value of alpha and beta. If it turns out that the utility returned from min is greater than my utility, then I've learned something new. I will update my utility to be higher, identify which move it was that caused my utility to move higher, and set the move OK to be true. Now, if the utility that I've uncovered is better than any of my min ancestors will allow, then I might as well break out of here and not consider any other moves. Meanwhile, if this utility is better than my alpha value, I should update my alpha value to send down to any of my child nodes. Let that repeat out, and when it's done, I'll return ply data, which again will have been updated to have the largest utility and the move that caused that largest utility. Okay, moving on to min. Now min, once we've figured things out for max, min is usually pretty straightforward. We just have to put on our thinking hats and think of how to destroy the player, not how to build the player up. So it's useful to check and see if I'm player 1, then my opponent, the min player, will be player 2. Otherwise, if I'm not player 1, then my opponent will be player 1. If you haven't seen this tertiary operator before in C or C++, you can go Google it, but it's basically a built-in if statement. Okay, we again copy the board, get a reference, constant reference to the list of moves, loop over that list of moves, copy the board, and excuse me, apply my opponent's move. Remember, this is a list of my opponent's moves. Call max, again passing on the modified board, the player who I am. We're always talking about who I am, and the next step passing on min nodes alpha and beta, which it initialized from its parent. Okay, because we're looking to minimize the player. If the utility is less than the best utility this min node has found so far, we update the utility, the move, and so forth. If it's less than or equal to alpha, there's some parent or other ancestor max node that will reject us, so we might as well break. That's our pruning, right? And then we will, if we need to update our beta, we will, to pass on to our descendants. Okay, so we've ran through really quickly pick, move, max, and min. I think they're syntactically correct. I want to now go back into the agent program itself. So let me split the screen, and then the lower part, let's go back to AI sample alpha beta CPP and go to the agent program and see how it actually implements and uses pick move. So there's the whole of the agent program. Oop, my bad. Okay. The agent program for alpha beta in Mancala. Let's go to the agent program for John Carter. See what we mirror and we need to keep and what we need to get rid of. So first off, we need to create a Jetan action. That makes sense. We need to get the board the board percept and use that board percept string to initialize an actual board object. We need to get the player number, and I'm using a string stream up here to do it in Jetan. I did it differently with A2I, non-C++ way in the Mancala. Okay, so here's the main piece then. After we've initialized our data, we will, instead of acting randomly, ask pick move to pick a move given the current board and our player number. If there was an actual move in there, move OK. Then we will do a Jetan action move with the move, setting the move to be the one in apply data. Otherwise, we'll do a Jetan action quit. That means there were no legal moves that we chose. It'd be kind of weird, but okay. Best to cover our bases, and then return that action. All the rest of this was just to choose a random move, which we no longer have as a possibility. Okay, my biggest question now is, does the Jetan environment action class really have enumerations called move and quit for codes for moves? So let's, in this bottom screen, go back to the Jetan board. Okay, so Jetan action right here. We'll define the codes that we have for moves in this environment, and indeed we do have a move and a quit. So those should be legal symbols for us with hopefully the correct intentions that we're looking for. Okay, we've now got a minimax with alpha beta in it. What we don't have to complete this is the evaluate function. We declared it, but we haven't defined it yet. So let's go back to AI sample alpha beta implementation and go look for evaluate the method. And in the John Carter CPP file, we'll add that in. John Carter. We didn't change the way that this method was being called up above, so this same signature for the method should be fine. And this relies on calling the Mancala score per player on a board. All right. Let's go back once again to the Jetan board header file, and we will go again through all the methods that are declared here. There's a bunch of constructors, a destructor, some move methods, a quit method, is legal, winner, have winner, determine attacked locations, determine legal moves, get last moves, get player times, get total moves, get board. That's interesting. Okay. Set board, get board string, set board string, init board, set total moves, set last move, set player time. So I don't see anything called score in here. There was a get board which returned to us a board data. Let's go look at the board data class. The board data class does not have a score method. So we can't use this simple heuristic evaluation function straight up. We need to do some other kind of simple evaluation function. I'm going to do it I think like this. So there's a collection of pieces here. Each of those pieces belongs to one player or the other. I'm simply going to calculate the score as see who has the most live pieces. Okay. Make it a double, set it to 0. So for int I equals 0, I is less than 20, I plus plus. So this will loop over the first 20 pieces who belong to player 1. And so we're talking about, ooh, I need a board data. Let's do a const board data reference board data equals board.get board. Ooh, looks like it's a capital G. Okay. So that should loop over the first 20 pieces, which for every one of them, I would want to take live pieces and add to it 1 if it's my piece. So if player is equal to 1, I want to add to my pieces, right? And otherwise, I must be player 2. So any piece that's alive for player 1 is going to be counted against me. So I'm just counting up how many pieces I have alive minus the amount my opponent has alive. And then I'm going to repeat that for the second half. Let's start with 20 and do less than 40. And if I'm player 2, I'll add. And if I'm player 1, I'll subtract these pieces. And then I'm going to show return live pieces. Now what's wrong with that? Well, I wasn't taking into account the fact that dead pieces should not be counted. And so if I look at the piece class, there is a data member called mAlive. And so I'm actually going to say if let's see, board data sub pieces sub I dot mAlive, then it counts. Okay, so just count up who has the most live pieces, and if you're starting to win by more and more live pieces, then you're winning more and more, and that's what the basic evaluation function will be that I'm going to try to use. Alright, I am very nervous. I have just worked on, let me see here, 150 lines of code roughly, and haven't compiled once, so that's probably going to be a little bit of a build nightmare, but let's go see if we've been able to anticipate all the issues. Okay, we've got inside the, what function is this? Line 119 of the CPP file, I've got a data or a variable that's not being used. Let's go look at 119. Okay, that's in the evaluate function, and that's because I really don't care who my opponent is. I kind of know who my opponent is by who I am explicitly by doing these if statements, so I don't really need that. Get rid of it. Wow, okay, so that's a little surprising, but we were able to get it to build at least. Who knows if it's actually going to be running correctly. So we're using max depth to determine when to stop unless there's actually a winner to the game. What value does max depth have? I never set it. That's bad. Okay, I'm going to go back to AI sample alpha beta CPP. When does it set max depth? Okay, it defaults to 3. Let's go ahead and use that default in our code too. That seems like a reasonable place to start. Okay, let's see if we can build again. Yay, it built. Let's see if by any chance this agent runs any better than random. What I'm thinking is it's going to not really perform well until it actually sees a way to get a kill, and after that I see it being aggressive and trying to get more kills. Let's go ahead and launch it. Hey, John Carter is playing from Underneath it's the black pieces playing against the white pieces. It looks like, again, because everything's being valued about the same, that it's picking one of the first moves available. Okay, let's see. Is it thinking? Here's the game over. Did I lose? Did I win? The game ended. And I wasn't paying close enough attention to see who won. So over here in this upper right corner, I see a bunch of files that got created, including this server log. The run Jetan script has builds that, and this has a trace of all the moves that were made, which are less useful. But more important to me is this final report that will come out even if you don't trace the moves, and it shows that John Carter won. Notice their score was 1 versus the score for random, which was -1. So John Carter won with a total of 1.8 seconds of think time. Interesting. Makes me really curious if I can win again. John Carter happens to be playing from the bottom again. There's no guarantee to that. It's probably random. And I'll point out that Thote is the first one moving most of the time again, because all moves are equal, and that's probably the first set of moves that are in the moves vector. Once he can see a way to force a capture, though, I expect him to become more aggressive. The only reason you see much time going here between moves, neither agent's spending much time thinking. The only reason is because we have a 1 second delay in there, so you can actually observe. Now you can see John Carter's getting more aggressive with that Thote in the top left corner. He's got a flyer out in the bottom right. The princess is standing out there in a very vulnerable spot. Let's see where this ends up going. Yeah, he's being aggressive about taking pieces, because every time he takes a piece, he has a higher utility. He doesn't really know the difference if the princess has been captured or not, so he doesn't look like he's aggressively going after the princess particularly. Okay, and this game doesn't play out the same as the last game because random is random. He doesn't play the same, so John Carter will have to play differently each game. We're actually only up to a total of 3 seconds of think time so far. How's this game going to end? Oof. So the white player, the random player, lost its chief a long time ago. It looks like we might have actually ended up in a draw because the princess wasn't captured, but the white player had very few pieces left. We look at the server log at the end again. Yep, indeed it was called a draw in this particular case. Okay, so obviously there's things I could do to improve the evaluation function, but there I have at least a somewhat working alpha beta agent. And I could go from here to improve things. So far we've taken 38 minutes to do our work. I'm going to continue on with just one more change. I'm going to add an additional evaluation function and allow that evaluation function to be selected or configured when we run our agent. So I'm going to go back to the alpha beta for a little bit of inspiration, although there's no inspiration there. I'm going to go look at the alpha beta random evaluation, I guess, and I'm going to go into the header file first, and I'll see that there's an enumeration here in this agent that gives a different number for all the different kinds of evaluation functions that it has built up. And this one has a whole bunch of different evaluation functions chosen. I don't want tons of them, I just want to have 2 of them at this point. I'm going to go to John Carter's header file. That is not the right one. Let's actually called AI.JohnCarter.h, right? Okay. And come up into the John Carter class under the public no, this is actually outside, so I'll go outside as well. Let's enum John. I'm gonna keep mine inside the class. Make it public. Enum evaluation. Options. Okay. And we're going to keep the piece count as one option, but I'm going to add to it piece count, but also check for wins. So that would make it more aggressive. If it had a choice, it would presumably choose to kill to capture the princess as opposed to capture any other piece. That's my intention there. Okay, that means I'll need a data member to track it. Notice we have one down there in the Mancala agent. We're just going to add the evaluation method. So instead of making that an int though, let's make it correctly typed here. Let's make it a evaluation option type. Okay. And then let's go look in the sample alpha, beta, random evaluation CPP for the evaluate function that they use. Evaluate. And notice how this evaluate function is really nothing more than a switch statement to call the correct evaluation method. You probably saw this before when you implemented your heuristic options in the Rubik's Cube class. So let me go to AI John Carter CPP, go to the evaluation function, and now this evaluation function that we have right here is actually evaluating by piece count, right? And so I'm going to make it so that the evaluate function itself will say switch on this evaluation method, and then if it is piece count, we'll call p equals evaluate piece count, passing in the board and player. But if it's piece count with win, then we'll call a different method, and I am going to say that the piece count is my default. So that's intentionally falling through. If nothing is selected, if it doesn't match either piece count or count win, then we'll take piece count as the default. And then finally, we'll just return the value that was selected. And I think that's the same as what we have going on down here. Okay, now I need to then, in my header file, I need to declare this method and the piece count win method. And then go implement the piece count win. Alright, piece count win will look like piece count, kind of. So I'm going to copy it to begin with. And again, this intention is if the game is over, to give an appropriate score, and if it's not over, just to do piece count. And so we'll get the board data. Let's see, we want to check, how do we know if the game is over? We can tell by looking at player turn. Okay, so if the value of player turn is equal to 5, then player 1 wins, right? If the player is 1, that means I'm a winner. Else, I'm not player 1, that means I'm a loser. Okay, so that means if I'm a winner, I want to give back, what's the name of that infinity? My infinity over 2. I'm just going to return it. Alright, otherwise I lost. My value is negative infinity over 2. Alright, else if player turn is 6, that means player 2 won. And if I'm player 1, that's bad for me. If I'm player 2, that's good for me. And meanwhile, if it's a tie game, that is bad. Well, not good, not bad. It's a 0 for me in either way. Okay, so if the game is over, I'll count it as either good for me or bad for me, or neutral if it's a tie. Otherwise, I just want to return what evaluate piece count would have done, rather than re-implement piece count. Okay. So the intention with the infinity over 2 is we want these numbers not to be as extreme as as this full-on infinity, which means that we don't know anything yet up in the min and max moves. But we wanted to make sure that it's big enough that it's more extreme than anything that piece count could add up. All right, that should allow me the ability to choose. Let me go back to AI sample alpha, beta, or random evaluation CPP and look at how they do the initialize the evaluation method. Well, they initialize it in the constructor first. Okay, let's go to AI John Carter CPP to our constructor right here. And we're going to initialize it to, which one did we want our default to be? Piece count. But we're also going to allow the user, if they give us a number, through the -v option, that we will take that value, that's -v or -user2, sorry, and we will hope that that actually evaluates to one of our evaluation enumerations that we have. Let's see, and then now that because of the command line options, I might have different versions of John Carter, right? I might have one that has one evaluation function versus another evaluation function. I'd like to run them against each other, for example, and be able to tell the difference in the server output. Notice that in the server output that you get the name of the agent displayed here. So I'd actually like to modify the name a little bit to match what is being configured. So I'm going to make a string stream here and configure it with the intended name, which will be John Carter as a basis. But I'm also going to add to that name a dash followed by the evaluation method. And use that, as the name. Let's actually do a dash E for eval. Yeah, so that would be a dash E1 or dash E2 or a dash E0 or something like that. Let's see what that does now. Okay, it's going to be upset with me. The compiler's going to be upset with me because I'm taking an int and trying to put an int where an enum should be. So let me say I know it actually should be an enum static cast into evaluation option. I believe that was the name of the enum, and try that build again. Okay, it compiles fine. You know, I can't resist. While I'm here, I'm also going to add so that max depth can be not the default if we don't want it to be. So this is either dash U or dash user1 to set the max depth. So if it's actually configured, we'll use that instead. We already have our defaults for both of those. Okay. Still builds, right? Oh, that means I should update the name to use D for the max depth. Okay. Finally, which agent do I want? Well, I want to run for the Jetan agent arguments here. I want to run John Carter with a depth of 5 now, and I want to run it with a evaluation function of piece count will be 0 and piece count win will be 1. So I want to do evaluation of 1, which I think piece count win would be stronger than piece count itself. And in order to really verify myself, I'm going to come back into run Jetan and make the first agent. Here's the first agent, which has been random up till now. I'm going to just make myself not play against the random agent anymore, but play against myself with a depth of 3 and evaluation function 0. And so see if going to depth 5 and having evaluation 1. Let's play at the same depth to see if that evaluation function 1 versus evaluation function 0 makes a difference. Let me make sure I'm completely up to date, and I could do a run. Okay, I'm not going to wait for these results to happen. I'll be able to compare those results later, but it's going to take a little bit of time because we don't have a silly random agent to play against this time. Thanks for paying attention. Good luck in implementing your agents. We'll see you next time.